Here's a quick hot take on computer science exam. Um, it was not so bad. Overall, I thought like maybe not as easy as last year, but it was still pretty good and very accessible to most people. So I'll just fly through it real quickly. Question one, programming question. The percentage sign, the modulus here, and the floor division might catch out a few people, but not. It's not that bad. It wasn't too bad at all. ASCII Unicode, totally standard. It's a very short topic, and that theory is included in the topic. So like you can say what the difference between ASCII and Unicode are. Maybe when they ask memory usage and compatibility, those words are a little bit, you know, more flowery and technical than might catch a few people out. But really, what they're asking here, they're talking about like how much ones and zeros, is used by Unicode versus ASCII, which is only 128 characters, the original one. So you're just comparing the two. Um, Question three is a computer science computational thinking puzzle, and that's always lovely because people get them and they're like, I didn't even need to study for that. And good job, you. If you're a Sunday puzzle person, you'll fly through those questions. Question four, that was a tricky question. If you've ever hit Control Alt Delete on your PC and had to figure out why it's so slow, and you're looking at like the CPU usage and memory usage, you'll know what's going on here with resource management. Like what's using up all my RAM. Um, where like file management is saving space by deleting large, 8K videos. So yeah, you would have done those two things, but did you know the name for them, like resource management and file management? So that I think a lot of people will get tripped up by, but they really know what it is. It's just fancy names for things that they probably already do. This looked scary for a moment, but then you realize instead of one kind of longer question, it is three very short hex to decimal um, conversion questions. So lovely. You're just doing three little tiny ones instead of one slightly longer one, and then write them beside each other. So lovely, not so bad. Why will a computer take your job? It will never do it. Don't worry. Your job is secure. Yeah, very easy question to come up with. Um, I thought this was a lovely way of showing the linear and binary search algorithms. That was pretty cool. I like it, pretty neat. So I liked it for that reason. Although I didn't have to sit an exam. Um, so yeah, it was just name the linear and binary search. I mean, there are only two search algorithms on the course, so name your two children. Hopefully you don't forget. Which these two algorithms is more efficient? Well, you can count how many passes it says it up there. So I think most people who guess that will just get it right. Look at the picture. Oh man, VoIP. So IP, fair enough, right? You need to know what an IP address is. And there are many other terms they have not asked, like maybe what's a MAC address or that sort of thing. But like of all the many technical terms they could have asked, I just think VoIP. I mean, yeah, most people won't ever come across like a VoIP is voice over IP. It's just like an internet phone, right? But unless you install those in a school, like who would be familiar with that? Not many people, and even people growing up in industry are not going to end up having to. It's just very niche. It's not unfair, but it's if you had to pick all the things to ask, I'm just very surprised that VoIP came up. I think it's because it was written down in the specification. And so they were like, well, maybe we'll just pick something that we did say and highlight. So in fairness, they did, I suppose. But like, I think a lot of teachers didn't spend time on it because like, who would, it's not like AI or TCP where things you'll grow up and everyone will use. Anyway, that's just my opinion, man. So I would have skipped that one with the VoIP, because I wouldn't have known what that was when I was a student. And then there's spot the syntax errors. Lovely, not so bad at all. That's totally fine. And then this one here, though, a logic error. So they'll look at that and think, I don't remember getting like a logic error in Donny. That's weird. Like, what is that? And that just means your program is run. There's no error, but you get the wrong answer. Um, but I think that will trip people up. So they're like, did they need to call it a logic error? That's what a lot of people call picnic. problem in share, not in computer. It's the human. They could have just asked, what is actually wrong with it. I don't know if they needed to say a logical error. So maybe just a little bit jargony, but look, we'll know for next time. Um, so unless you're in sixth year, in which case next time might be college. Two examples of how compute. Look, what I asked some religion teacher who was lovely and answered that question with full marks. So if you can't say what you can automate with a computer and you've done computer science for 2 years, here now. Okay, so like shopping market tills, like that can be automated. Driving can be automated to self-driving. Limitation: if you choose not to use lidar and rely on cameras, you can crash. So look, there's loads of things you could write there. Social media advantage. I mean, that's just your SPHE lesson if you were awake for that. So this one, I mean, there's loads of these questions that people off the street could just answer if they were clued in and kind of, kept up with the news and thought about their existence in life. They'll be able to answer these. But they're a little bit soft in that, like, unlike this binary one up here where you can just say, I know walking out of that exam I got that 100% right. With these, you're like, I just wondered if I gave acceptable answers or not. So yeah, a little bit maybe softer. And this is from last year. Totally fine. Like, you can talk about the ALU or the registers or anything inside the CPU. Only thing is, some people might not have looked at that because it did come up as a long question last year. So it's probably on people's last thing they would study. But, I think most people going for H1 would have looked at it, and it's totally fair. Cool. So section B, responsibilities. That was in a previous question. So nothing too hard there. This whole question was really nice. Like if you've ever just talked about a software company and what job you like in the future, all these kind of things, or you've gone through a project, a group project in class. So all of these things are just, they're very like two features. Now, the two methodologies they were looking for, I mean, most people will go agile and waterfall, right? And then you have to just pick one that you like and say why that's good. And, just this is where you just learn off the table of 3 good things and 3 bad things about each, and then you just name them, right? So stakeholders, what do people want? I mean, I just feel like that's kind of common sense. You wouldn't have to study computer science. If you study business, you'd probably get that, or if you were just a person who could speak English and read the question. Yeah, I think you're fine. So you've identified database management, 2 specific uses. So maybe you might not be thinking about that. Like, why would you use a database? Things like, multiple people logging on at once. If you just had a CSV file that might overload, so you might want to use a proper database. Things like that. AI, sure, I thought there'd be a little bit of AI in here. So yes, how could you use AI on this? That's easy. Sure, AI is in everything. There's loads of ways you could use AI for vision or prediction or anything like that. And assistive technologies, that's been asked a few times. And so it used to be in the coursework, actually, they would always ask us a bit on assistive technologies. So anything like, reading aids or talking out loud, text to speech, any of the things that just help people. Like, when you click like the assistive technologies button on your phone, anything that appears on that screen can probably go there. All right. This one, not bad if you read it as like system and function, system and unit testing, which is what it was traditionally talked about, like in the coursework. The only thing is, this one says functional testing, which some people might mix up with function testing. Like, let's say you have one function that does the sound. That's a unit test. But functional testing, they mean the whole system. So, I mean, I would have called that a system test versus a unit test. But actually, from talking to students afterwards, most of them read it that way, and it was fine. It was not bad. So I need to hurry up here. So this one here was not so bad. It was just a little bit of Python, and then something on quicksort. So Python and then algorithms. So you're saying what is the purpose of like this is you're talking about like how a definition works. You go through it a few times on a trace table. That's been asked before, so if you've done past paper questions, you'll be okay. Um, you can talk about why one loop would be better here than the other. Um, this one here I thought was a little bit tricky. They've asked stuff about like recursion before, but I just don't know if people would be familiar with the phrase like the base case. I mean, you could if you got guess what it was, you probably would guess it, but like I just think that I have not seen base case used as a term in an exam before that I remember, so that might catch people out. Okay, and then a module that's looking for the remainder and that kind of stuff again. And that was actually in the start of the paper as well. So it's nice that they kind of asked that twice. Cool. Yeah. And then they're talking about limited RAM. Oh yeah. So this is just talking about, and that's kind of like how viruses work is basically if you just have a very inefficient program, like something with factorial and it skyrockets, uses up all your memory and crashes your computer. That's how viruses work. So it's going down that alley and talking about why we bother with all these things and think about what's efficient, what's not. Which is kind of why we're learning sorting algorithms. Because if you get lag in a game, if you're playing Fortnite, whatever, and everything slows down, it might be because the programmer chose the wrong sorting algorithm way up the chain. Just I don't know to figure out something. So, quick sort. Yeah, a lot of people thought that was going to come up, and it did because it was due. So that's fair enough, and nothing crazy here. Just the same sort of quick sort as last year's. The only thing I thought was a bit mad was where they said two common strategies used selecting the pivot. So like in their guide, they did kind of say, and the guide given to teachers, that generally the way they're doing it on the leaving cert is that the pivot will always be the last digit here. Okay. And to take that being the pivot. And then down here they say, well, what would you do? So if your teacher told you that, you might be thinking, well, what do you mean selecting the pivot? The pivot is this one. You can't select it. It's always the one on the right. But different versions of quicksort, you don't necessarily have to pick that as a pivot. As a pivot. So I don't know. I think a lot of teachers would have talked about that. Or when you're doing the examples, you got, oh god, that's an awful pivot. Like if you get one, or you get the biggest one, you're like that didn't help at all. So we would have all talked about like what's a good and bad pivot. So you probably could write something in there, and I think most people would be fine. But it might just be a little bit of surprise. This part here was very standard. If you can describe the best case and worst case for each of the sorting algorithms, you round that off. It takes a bit of time to learn off, but it's totally fine. Modeling simulation hasn't come up before. It was a nice one though. Not so bad at all. You're just like naming the output, name two inputs. Not so bad, you know. Some patterns that you can see. I'm pretty sure if I gave this to a primary school kid and they were just good at spotting patterns, they might spot a pattern. So totally fair, totally fine, not not so bad at all. Then okay, well, there are some variables. Could you give two example variables? So again, that's kind of common sense. You could write whatever would fit there. All models are wrong and some are useful. That's a lovely quote. I've heard that before a few times. It's lovely, and nice that they put in the exam. So it's just saying like this isn't perfect. What we're talking about, like it's been on the paper before, algorithmic bias, where there was like a family discount and it didn't work out if you're a single parent. So you're just talking about how some models can be wrong, like if you're looking at the wrong thing. So it really depends on your training data. Like for example, if you go and you're training x-rays to spot things, people don't go to the hospital when they're healthy. So then all of your training data will be of sick people generally, so it'll be biased. So there's some like limitations to modeling simulation. Why abstraction is important. I think if you wrote anything in there that was reasonably sensible, of abstraction is just kind of cutting out the BS and only worrying on what's important. So like if you're measuring counting people going into a room, yes, it is true that the humidity goes up as people go in, but that's not like the deciding factor. The deciding factor should be like a laser tripwire that just triggers when they go in. Like that's what you want to be looking at, not like not secondary, tertiary, or distant nth level effects that yes are there but aren't really as important. So that's what abstraction is all about. It's worrying about what really in a model what's most significant, and what's practical and scalable. Um, then yeah, they talked here how it could be used to address a problem. I thought that was pretty nice. I mean, you know, you've all lived through COVID, so you've seen what NFET did with modeling and that sort of thing. They used to modeling and simulation used to open and close the whole country. So, you know, it's not like people haven't encountered this before. Health agency wants to predict an infectious disease might spread. Yeah. Speaking of, how could you agent-based modeling? So like if you have little agents as students who would run around, you could do a simulation that way. One emergent behavior, so things that you might find from that kind of come from it yourself. So, yeah. Again, they've asked emergent behavior and agent-based modeling before, you know, so if you've done your past papers, it's not so bad. And lastly, one strategy that they could test a model to reduce rates and explain how would you measure success. So, okay, yeah. So you're just saying one thing that you could test in this model, which is very similar to the questions above where they were saying, okay, well, can you think of your own variables? You know, so if you've made some models before, or you've played around with stuff like that, you can even just use your imagination. What else could you do? How could you make this better if you had like if I gave you an extra $1 million? You know, how could you do this? And that is one thing that I think most people will say when you talk to people who do modeling for a living. You have all this simulation, but how do you actually test it works? So like if you have a rocket simulation, you think, oh, my rocket's going to take off without blowing up. Yeah, but how do you actually test that model? You need to bring it to a test site, test it with an engine, and be like, look, my model versus reality. You know what I mean? Cool. All right. So I thought all in all, and not a bad paper at all. It was grand. I just thought that maybe if you're looking for H1, there were a lot of softer questions where you probably will get your H1 if you've done your study, but leaving the exam center, you might be like, "Ooh, I wonder if I got the mark for that," you know, rather than things like these hex and RGB questions. Like you'll just know because you know you got the right answer and you can double check it. You know, you can go the different route and convert a binary to check your answer. You know, where the Python stuff, like you can go back and check it. You're like 100% I got that right. Um, and very quickly, I don't have it here, but I'll talk about the programming exam. Yeah, the programming exam was grand. Section A was totally fine, except for a part 7, where there was a string, like a consecutive series of increasing numbers. Wow, that question, man. I don't know if anyone's gonna get that. Like, and my understanding generally was that part A, like 16A in section C is just skills. So like, can you do min max? Can you do an if? Can you do a definition? You know, it's a tick list of skills where and then section B is more the 16B is more the creative, like can you just an open-ended thing? Can you figure this out how to do it? And actually a lot of people from talking to them were totally fine with A and B, but just that last part of A was a real like I don't know, where it just didn't seem to fit into anything else. It just seemed like a really nice question if you had an hour and you weren't under pressure in an exam. I just didn't know if that was section A, part 7 was the place for anyone to see that written down on paper with a time constraint and pressure. So yes, that was a general consensus from students is that they were all fine with the programming except for A part 7, the consecutive numbers. That was a doozy. Um, so hopefully we just never see anything like that again on Leaving Cert. And that's not the beginning of many random interview questions for a software company that you would get. So anyway, have a lovely summer and enjoy all the long ChatGPT graduation speeches. Make sure to bring a bingo card with versatile, dynamic, and all of the adjectives on it.